So in this video we have the intent of this video is like we are going to implement the ICP12 for deep learning lesson 5, in which um, we are going to implement the LSTM model, and the use case which we have is like the sentiment analysis on the Twitter dataset. So this is the ICP which we are going to cover into this video. So we already have a source code provided by the lecturer, by the professor into the class. So the first task is like we have to save the model, and we have to predict the new text data which has been provided. For example, it's given over here, and we have to predict using the saved model. And second question is like we have to apply the grid search CV on the source code, the same source code which has been provided into the class. And third one is like we have to apply the code on the spam data. So this is the different data set which has been provided into the class. So this we are going to implement all these three into the Google Colab notebook. So I have implemented this one into the Google Colab. So this is my code. So first we have imported all the libraries, and I have imported the basic CSV file which has been provided, that is the sentiments.csv. So this file has been imported to the Google Colab, and so here we are reading the CSV data. So this is all the part of the code which has been given into the class. So we are reading the data into the pandas data frame, and we are taking care of only two columns, that is the text and sentiments. So text is nothing but a tweets, and sentiment is like we have three different variables like positive, negative, or neutral. So this is like the our output basically, so which we have to predict. So before feeding the data into the model, we have to format the text or the tweet. So we are converting that one into the lower in case, and we are removing all the special characters from the tweets. So after doing it, so this is our output. Like we can see, it has been removed all the special characters and it has been converted into the lowercase. And this is nothing but the sentiment column for the data frame. And here we can see the count of all the data. Like for the positive, we have 4,472, and the same way we have for the negative and the neutral. And we can see here like we have a RT like for the uh, value, like the retweet. So that we have replaced with the space here, and then so all after all the formatting of the tweets, now we have to change twist to integer. Like we have to do the tokenization so that the model will understand, because all the models works on the integer parts, because they have to give the weights and they have to do the calculation. So we have to convert the words into the numericals, or say integer. So we have used the tokenizer here. So it will tokenize, like we have created one object like the tokenizer, and in which we have fitted the column text from the data. So it has been fitted on the this object tokenizer, and then we have changed into the sequence. Like it will, each tweet will have a sequence of the data, and the length will vary for each. So we have done the padding, so it will do the padding so that the length will be the same for each tweet. So this is the output after converting the tweets into the sequence, and after doing the padding. So this is how it will look like. And here we have defined the model. So we have given the embedded dimension as 128 and LSTM out as 196 here. And this is the function which has we have defined, like the create model, in which first we have defined the model as a sequential, and we have given the embedding uh, layer first, the maximum features and embedding dimension, which we have defined here 128, and the input length will be nothing but the x dot shape 1. So x is here, like after the padding we got the shape, so this will be the so one tweet will have a length. So that will be the input for the model. and we have added LSTM and the dense layer. So we know the output we have a 3. So the output layer we have a 3 neurons, dense layer with the 3 neurons here. So here, and as we have already formatted the tweets, so we also have to do the hot encoding or level encoding for sentiments column, in which it will be converted into the numericals or integers like 0, 1 and 2. So we have a 3 different types of output here. So we have changed that one so into the integer. So y will have after the categorical integer encoded value, the y will have that value. So then we have split the data into the train and test, and here we are creating the model and evaluating it. So we have done the with the epoch of 5, and this is like we are fitting the model with the trained data, and we are evaluating the model with test data, and we are calculating a score and accuracy. So the law, if you see, the loss is significantly large, 82.82%, and the accuracy is 67.1% on the test data here. So now this is the part of the main of the question 1, in which we are converting the model to the JSON file. So here we are converting the model into the JSON file, so it will save the model into the JSON file, and the weights will be saved into the H5 format. So after so we have saved that one into the name with the model.h5, and here the model.json. So here we are loading the model basically from the whatever the model we have created here. So we are loading the model, and we have given the model as a loaded model here. Then we are evaluating the loaded model. So first we compile the model and we calculated the score for the whole x and y, whatever the input we got earlier. So we evaluated that one and we calculated the score. So here in this case we got the 78.29%. So now this tweet, for example, like this tweet has been given into the question 1. So we have taken this tweet and we have implemented the same logic. Like we have tokenized this tweet and we have done the pad sequencing into the tweet. And so the tweet is ready so at this stage tweet is ready to give the input to the model. So the loaded model has, we already have seen here, like the model which has been loaded after the saving, we have given the name as a loaded model. So here I have given the loaded model here to predict the tweet which is coming from here, and batch size 1. So it will predict the sentiment of this tweet. So and here we know it will give the probability, so we have given the sentiments as so here it will tell us like with the if else logic, which is the negative, positive or neutral. So after running this cell, we got like so this is the probability figure. If you'll see, the first one is like the highest probability, that is showing as a 48.48%, and the first one is for the value 0. So the index value of this probability is 0, so it is for the negative tweet. So we got like this is the negative tweet. But if you'll see, this tweet is really not a negative one. But yeah, this is how the model has been defined, because it's not the 100% accurate. And for the bonus question, I have given the history here. In the history we have epochs, and I have run it, and I have stored the data for the for validation and the loss here into the history, and we have plotted here for the history for the train and test. So this is the model which has been plotted for the accuracy, and here is for the loss. And then I have applied the same thing into the grid search CV on the source code provided to the class. So I have taken 3 epochs, and the best score for the grid search we got like the 67.33% with epoch 3. As a part of question number 3, we have uploaded the file again. Like in this case, we have uploaded the spam.cvm CSV, and as we see, like here we have a v1 and v2, in which v1 has only 2 values, ham or spam, and v2 have different data. So we have done the same thing as we have done for the tweet. So here the same like in the earlier file we have v2 column here, and v1 is like our output. So for the v2 we have converted into the lower case, and we have removed all the special characters from it, and this is the view of first five data. And also we did the same thing for the tweet, like we have removed the RT. So basically there is no any RT into it, but we ran the same code. So this is the part of the same code. And here we have taken the maximum feature as a 2000, and we have tokenized, and we have converted this one into the integers. And we have done the level encoding for the output layer, which is nothing but the v1 column, which is like ham or spam, this one. So in this case we will have a two value 0 or 1. And so here in the output we have a two neurons, like we have only two outputs in this case, and we have given the x shape as the input length, and we have defined the same way it has been given into the ICP, but the layers we have changed it to 2, because in this case we have only two outputs. So here we have saved the logs into the tensor board, and model has been created using the create model here, and we have fit the model with the history so that we can plot the model with the validation and the training data. And we also evaluated the same model with the test data, and we have saved that one into the variable score and ACC. And also we have saved this model as a mymodel.h5. So after running with the 5 epochs, we got it. This is the loss, and this is the accuracy of the model. And here, as we have saved the fitting data value into the history, so we have plotted for the loss and model accuracy. So this is the blue one is for training data, and the yellow one, orange one is for the test data. So this is the accuracy over the data during the fitting of the model, and this is the loss of the data. So we can see the loss is decreasing and accuracy is increasing as we move across the epochs. So this is the model which we have created for the ICP 12. Thank you.